In this video we want to talk about box plots, sometimes known as box and whisker plots. Now this is another way of representing data, very straightforward method for representing data, usually small data sets, but it's a way of showing pictorially what the data is illustrating. So it's a very straightforward exercise. A box plot, sometimes called a box and whisker plot, is a type of graph used to display patterns of quantitative data. So please note here it's not qualitative, and it is, generally speaking, discrete data. If it's continuous data, it's divided up into units which make it amenable to counting as if it were quantitative data. So it's straightforward data, and it's a way of representing that data. It splits the data into quartiles. Now a quartile, you'll remember from elsewhere in your studies of introductory statistics, is just a quarter of the data. And we have Q1 is the first quartile, which represents the first 25% of the data. The second quartile is between that and 50%. The next one's between 50 and 75%, and Q4, the final quartile, is from 76% to 100%. So a box plot splits the data into quartiles. So 25% up to 50%, up to 75%, up to 100%. The box goes from the first quartile to the third quartile. So in this case, the box is picking up half the data. It's going from the first to the third. So it's not including the first quartile, and it's not including the final quartile. So it's including the two middle quartiles, Q2 and Q3. So it's going from the first to the third. The second quartile, Q2, is also indicated. This is the median of the set. The second quartile must include the median. The median is the middle point of a data set. So half the observations are above and half the observations are below. That's the idea of the median. The average takes into account the values of the observations. So some values may represent more than others, and hence it's not the median. The median is the middle value. Two horizontal lines called whiskers extend from the box on either side. And we'll see what this looks like in a second. One whisker goes from Q1 to the smallest non-outlier in the data set. The other whisker goes from Q3 to the largest non-outlier. So if we look at the picture here, we've got some data. The data ranges from -300 to, let's say, 500. Here we're looking at the various representations that we can get within that data. We have outliers indicated by the stars. We have the smallest non-outlier, which is about at -100, roughly speaking. We have the largest non-outlier, which is somewhere above 400. And then we have the first quartile, the second quartile, and the third quartile indicated. The box is defined by the first quartile and the third quartile, and the median is at Q2. So we have an idea now of what we mean by a box plot. We are taking the data into this box, and we're saying we're looking here at the data from Q1 to Q3, and we're excluding the very large items, we're excluding the very small items. If the data set includes one or more outliers, they are plotted separately as points on the chart. So Outliers are indicated separately. An outlier is an extreme value that doesn't fit the pattern. So it could be indicated, but it's not necessarily taken into account. It's an outlier. The box plot below, the one we're coming on to, there are three outliers lie in front of the first whisker, and the two outliers follow the second. So if we have a look at that for a second, we see here that the three outliers in front of the first whisker. So on the left we got three outliers. In other words, they're extreme values. They don't fit the pattern, so we're not going to take them into account. We recognize they exist, but we call them outliers. But we do take into account the smallest non-outlier. That's the one which does fit the pattern, but it's the smallest. So we take that into account. We have two outliers on the right hand side as well. Don't again fit the pattern. They don't fit easily with the rest of the observations. There's something strange about them, something causing them to be out there. So we would call them outliers. And we produce the line to touch the largest non-outlier. Now the median is indicated by the vertical line that runs down the center of the box in the box plot. The median is about 95. It's difficult to say where it is. About, if you look at Q2 here, that's the median. It's about 95, thereabouts. Additionally, box plots shed light on the spread of the data in the set. So we can use box plots for looking at how the data is spread out within the set. We look at the range of the data. This is between the largest and the smallest observations in a data set. This is represented on the box plot by the horizontal distance between the smallest value and the largest value, including any outliers. So with the range, we do include the outliers. We just simply take all of the observations. We find the largest observation, we find the smallest observation, subtract one from the other, and that tells us the range. In the box plot below, in other words in this box plot, the data values range from about minus 330. If you look at the star on the left, on the extreme left, there are three stars on the extreme. It's about minus 330. That would be the smallest outlier. It ranges to about 520, the largest outlier. So the range is 850. Subtract one from the other. Subtract minus 330 from 520, and we get 850. Ignoring the outliers, the range is illustrated by the distance between the opposite ends of the whisker. About 10 to about 240. So if you look at Q1, if we draw Q1 down to the axis, it's lying slightly to the right of 0. Say it's about 10. And if we draw Q3 down to that axis, to that horizontal line, number line on the bottom, it's somewhere about 240. So if we ignore the outliers, we'd have something like a range of 250. The median is indicated by the vertical line that runs down the center of the box. In the box plot below, and we're going to come on to one, the median is about 95. Additionally, box plots shed light on the spread of the data in the set, as I said. So we can look here at what's known as the interquartile range, the IQR. The middle half of the data set falls within the interquartile range. The interquartile range runs from Q1 to Q3. And that really is the province of this box plot. That's what we're concerned with. In a box plot, the interquartile range is represented by the width of the box. In other words, Q3 minus Q1. The third quartile minus the first quartile. Now, in the chart we're coming to, that's this chart. In the chart, the interquartile range is equal to 240 minus 10, or about 230. So the interquartile range is the difference between Q3 and Q1. And again, the box plot represents this. It shows us where it falls. It falls in that range. Boxplots often provide information about the shape of the data set as well. For example, here we can see that the data is skewed to the right. There's a lot of data over from around the 240 mark across to 500, but it's skewed. The data is not sitting symmetric on the numbers. It's not sitting in the middle of the numbers. It's sitting off to the left. It could be symmetric. It could be equal, that the whiskers in this case are equal on either side. The one on the top on the left, it's skewed to the right. The whisker on the right is much longer than the one on the left. So the symmetric one, both are equal. And obviously the one on the bottom left is skewed to the left. The whisker on the left is much longer than the whisker on the right. So that's our talk about box plots and box and whisker plots, if you like. It's a very straightforward concept. It simply looks at quartiles, and a quartile is quite simply a quarter of the data. So we knock off the bottom quartile of the data, we knock off the very top quartile of the data, leaving us two quartiles in between. Leaves us 50% of the data. And that 50% we represent in the box. And then we can talk about whether it's skewed, the range. We can talk about interpreting the data. And it's a pictorial way of showing what's happening within a small data set. So that's all we're going to deal with here. Let's leave it at that and say thank you for watching.